Welcome to a new lesson programming the Commodore 65. Today again about assembler. So far we had now the introduction into assembler. We had this snake example where we had some practical assembler programming. So this is that much that I wanted to do in terms of introducing assembler. In fact, it's even more than I planned to do, because this last snake example got a little bit out of control. But so this lesson and the next few coming lessons will completely focus on things that are really special, dedicated to the MEGA65, to the 65. I mean, that's already the point about this lesson. I mean, the title of this lesson is completely strange. What's new in the assembler on the MEGA65? Usually would not make any sense for any computer, because if you have a new computer, everything is new. But this, of course, is very close connected to what is new if you compare it with assembler on the Commodore 64. So let's have a look. So from the last lessons you already know this picture, and today I take the chance to make it complete. So what I nearly have told you already everything. The only two things that are left to say is that the stack pointer also can have two 8-bit numbers, so can be 16-bit. And then there is a new kind of register, which is the base page. Yeah. And not yet explaining why they are there. Just because they are there are already some additional assembler commands just to read from them, or to fill them, or to do something with them. Yeah. So for this base page, you just have a command to copy it to the accumulator, or to copy from the accumulator to this register. So this means this is also the only possibility how to enter a value there, or to get a value from there. So there, for example, is no SDA for this register, so it's not really a register. And then also for this second part of this stack pointer, you have the possibility to copy it to or copy it from the Y register. For the first part, it's as you know it done with the X register. So you just have now these two commands in addition to get this 16-bit stack pointer. Don't be afraid, there are two possibilities to use the stack pointer. So you still can use it as you know it from the Commodore 64 with as an 8-bit stack pointer, and in this case the stack is also again located on the second page, also on page 1. But there is another mode where it can be 16-bit, and then it can be located wherever you want. And as I already have told in the last lessons, of course there is this set register, and so there are nearly all the commands that you know that are located around the Y and the X register. So you can increase and decrease as it was with the other registers. There is the command to store from them, to load from them, also in all these modes: direct, indirect, indirect, with index, and so on. There is the possibility to copy to the accumulator or from the accumulator. You can push or pull it to the stack or from the stack. This is even not new, but the possibility is now there. And the comparison, addition, and so. But this is basically, it's nothing new. And it's also from the semantics not new, and you don't have to learn something new, because it's exactly the same as it was with Y and with X. And the great thing is, we have now already seen more than half of the commands that are new for the Commodore 65. Yeah. So what else do we have? Okay, we have this status register. We already had this in one of the last lessons. The only difference is that there is an extended flag. And this extended flag exactly tells if you want to use the stack with an 8-bit pointer or an 16-bit pointer. So also this means that it can be located everywhere or only on the page 1. And of course there are then coming with this flag 2 new commands to set or to clear this, or to set this bit, this flag bit. That's all about this stack mode. Then I think this is also something we already have used during the programming. You have these commands to branch based on a flag that is set. I explained this already. The only new thing, so this is all not new. The only new thing is that there is now also a branch command that branches always. So of course you have the jump command, but to be in the same syntax and in the same semantics, there's also the possibility to have now such a branch always. Also interesting, this base page is now enables you to locate the 0 page to everywhere. Because the 0 page, the interesting thing about the 0 page is that you have these commands, like for example this LDA with only giving one 8-bit number, to access faster, or there are also some special things like indexing, which you only can do by using the 0 page. And the 0 page is the 0 page because the higher part of the address, so the higher 8-bit part of the address, is always 0. That's why it's the 0 page, and that's why it's the very first page, in the memory. But now by using this base page, you can enter here the higher level of your 0 page. So if you enter here 0, 0, and remember, you enter it by copying it from the accumulator or copying it to the accumulator. So by entering here a 0, 0, you would have exactly the behavior as before. But if you would enter here, for example, 0, 1, then your 0 page would be at the page 1. So it reads then from whatever is in the base page and what is indexed here. So you can place your 0 page to wherever you want. And the interesting thing is that during the program is executed, you can switch between different 0 pages. So I think this is one special key to additional magic in programming that will occur with when you see some special tricks on the Commodore 65. And then also interesting, for all these jumps there is a second version. It makes no difference for you in programming, it's exactly the same naming. The assembler will decide which one to choose, because there is one that behaves as before, which can only jump in a small area, because you only have here one additional parameter in an 8-bit parameter, so you only can jump in an area of 265, so about 250 in one direction and 250 in the other direction. And if you tried to jump faster before, you got an error because the assembler was not able to fulfill it. And now the assembler just takes another bytecode for this command. In reality, it's then another command, and this enables to jump based on a 60-bit parameter, and so you can jump everywhere. So you will no longer get this too far jump error message during the compilation. I'm not sure if you're still able to switch it on to get it as a warning, because maybe you want to avoid it, because I have not found it out, but I can assume that the execution time is different. So maybe you still want to avoid it, but it's possible now. So, and until here we had not really something new, and now this is all, or there's one more command. So on the next page it's a little bit complicated, a little bit more complicated command. Because of this I have one page only for that command, but in general, except for this one, this is all the list of the really new command. So it's really not that much. So there is a negation which negates the value in the accumulator. But what does mean negate? It's not just inverting, it's really doing this 2's complement, which means just inverting and adding 1, which sounds a little bit strange maybe at the beginning, but this is nothing else but by replacing the number this is symbolizing by its negative value. So you would replace, like for example here, 5 by this value, which is -5. And how do I come from here to here? I just invert everything, and then I add 1 to the result, and this is then exactly -1. Also correlated to negative numbers is this ASR, which is an arithmetic shift right. We already have this shift right, where there is just a 0 pushed into this number, and the rest is shifted to the right. So, and the difference with the arithmetic shift is just that it has a look at the first, or the highest value in this case, and if this value is negative, is a 1, then it pushes in 1 all the time, a 1. And if the starting or the highest value is a 0, it pushes in all the time a 0. And this is just then meaning that you are dividing by 2 the number as it was the semantics before, but now you would keep the sign of the number, and because of this it's called arithmetic. You have this also directly on the accumulator, or with an index, or on an absolute address. Then and then there are some commands which I would call comfort commands. So for example, you have an increment and a decrement, but on a word. So you give here an address, and then this address is, for example, incremented, and if it is incremented below 0, incremented. If it is decremented above 255, then of course it runs over to 0, but the next higher memory cell is also incremented by 1. So this is exactly what you would do if you would increment a word, and what you had done before manually. You also have incremented, and you had looked if it was jumping over the bound, then you would have incremented or decremented the next higher cell. So this is now here automatically integrated. Also you have now an arithmetic shift of a word, so it's just shifting now here a 60-bit value, so it's exactly doing what you have done before manually. So what is going here out, you're shifting it here in, and you have a rotate word, what is then doing the rotation also as you had done it before. It's doing it now manually. The strange thing is there is no rotate right. I don't know why it's not there. Maybe the left was easier to implement, or if you know it, if you have an idea why it's not there, or if you have found it and it is there, just leave me a comment. To me it's strange. It's really strange. Then also you have the possibility to push, or to to push a word either by directly writing it there, or by taking it from a memory address. So it would then take this value and the value from the next memory cell and push both to the stack. This is also, I would say, a kind of comfort function. And this is also a comfort function, but this is really, to my feeling, it's very useful. It's just an RTS, so you return from a subroutine, but in addition you give here a fixed number, 5. And what it then does, it does just an RTS, and in addition, after it did the RTS, it removes the number of given bytes in addition from the stack. So if you give here a 5, it jumps back. It removes, of course, the returning the bytes that were necessary for storing the returning address, and in addition it would return the next 5 byte, because we have given here 5, and leave the stack then there as it is. And to my feeling, this is very useful, because what you are usually doing if you're writing functions that you call, you hand over the values in the stack, and then you use them for the calculation, but for returning the values, or so usually you don't need it after you have returned from the function. Sometimes you need 1 or 2, but usually you don't need all of them. So very often after you jump back from a function, you are just pulling and pulling and pulling from the stack, and just you are not using this value, so you are pulling for nothing. And of course I assume that this operation is much faster. I have not found anywhere documentation or statement about the cycle times of those. So if someone of you has found, so please leave me a comment under the video, because this would be really interesting, especially for these COM4 functions, to see if those COM4 functions are really only COM4, so you just don't have to type and do it manually, or if at least there's also an advantage in the cycles they need, because this would then really be an advantage and would be really an argument, because if it only was the COM4, you would also, or it would also be possible to have this to be provided by the assembler, and in the background he replaces it with the commands. And then there is the map command, which is to switch the banks. We have a complete lesson only about this. It's lesson 8, so please have a look there if you did not have it yet. And then there is one command left. Here I just have placed for you the result of my experiments based on the ASR. So this is just what came out with the different shifts. So you have here some more examples where you can see what happens if I'm shifting arithmetic this or this number or this number. You can see then here the results. And then there is one last, not really command, because the commands are all known, so it's for the LDA and for the STA, but the interesting thing is that there is a new addressing mode. And I have the feeling that this is also quite useful, although I have not yet an algorithm in mind for it. And the addressing mode is the following, or what happens. So you write it, the notation is that you write it here in the TAS, you write it LDA, then you write here a memory area, and then you write here the S, it's a part of the command, and the Y, which is also a part of the command. And what happens? So what it does is the following. So it's not a memory area, it's a number. So it goes to the stack pointer, and then he takes this as offset of the stack pointer. So you also can locate directly to the stack pointer, but this usually makes no sense because here is the returning address located where you want to jump back. But if you know where the variable is, and usually you know it because you are the only person that filled the stack, you can then directly index to another position in the stack. Yeah? And then the computer takes the content of this, so he takes this as an address of the memory in the 0 page. You can use here again the base pointer, base page, to have the 0 point wherever you want. So you see the things are matching good together. So it takes the content of this memory cell and the content of this memory cell, and this together builds then an address. And then basically he reads the value from that address. But you can also have an additional offset if Y is not 0. If Y, for example, was 1, he would load the content from the address 1, 2, 3, 4. Yeah? So you also have the possibility to additional move with this Y. So it's like with the general index, Y indexed or X indexed, you always have the possibility to move over an area by increasing or decreasing the index or the value. So in this case you would have to modify the value on the stack. Yeah, and this is I think this is the most complicated and the only really complicated, beside maybe of the map command, thing that is new on the Commodore 65. And that's all. So in general, you have now the introduction to assembler. You have now all the commands that are new, except there is this shift right forward. I'm not sure about this, but in general, you know now all the commands, so you can now write all possible programs on the Commodore 65. This is not absolutely the truth, because what is of course now missing is how to access the registers and the meaning of the registers of the other processors like the graphic and the sound chip. And because of this will be the topic of the next lessons. So we will first have one lesson. The next lesson will be about debugging. It's very important that we come to that point that we are possible to debug, because programs will become more complex. And then, but the next the next 2 lessons will then be about the graphics and the sound, and then maybe interrupts. We will see if I'm that far at that time. So thank you for watching. See you in the next lesson. Bye.